All right. Good afternoon, everybody. And for those attending from the West Coast, good morning. My name is PolyPhaser, and I am the Business Development Executive here with MBSI WAV. And I'm really excited today to introduce one of our partners, Infinite Electronics, to our webinar. Joining us from Infinite is Jason Mies, who is the Director of Sales, and he will be focusing on both the Transtector and PolyPhaser product families that fall in the Infinite brand. Jason will be giving us a review of the key elements of surge protection and emphasis on best practices for protecting devices used in wireless, WISP, LTE, and other network applications. Before we begin, just a little housekeeping. This webinar is being recorded and will be uploaded to our social media outlets shortly after we are all done. So feel free to check out our YouTube, Facebook, LinkedIn. Every option out there, we'll find a way to get this out there. If you have any questions or comments, please feel free to drop them in the chat window as we move along. We'll be addressing the questions at the end of the webinar, but if we do run out of time, we will personally reach out and address anything that may be outstanding. If the chat window doesn't automatically open, there's an icon at the bottom which should get you where you need to be. We'd ask, obviously, please pay attention during the webinar as we will be asking a question at the end of the session. The first person to answer correctly will win a $100 Amazon gift card, but to be eligible for this giveaway, you must be a resident of Canada. Here at MBSI WAV, we're extremely excited to see Transtector and PolyPhaser continue to innovate at the core how service providers build and protect their networks today and for tomorrow. They address and solve some of the major issues facing the industry as it relates to surge and grounding best practices for a wide range of installations, including AC, DC, and PoE powering solutions. Keep in mind that we at MBSI WAV can help with planning, network design, post and pre-sale support on every piece of a wireless project that you might have. I don't want to steal any more thunder, so I will turn the floor over to Jason, who will be running the show today. Jason, over to you, man.
Thanks. No thunder, is that a pun there? Because we're talking about surge protection, right?
Oh, you got that.
I did. All right. Nicole, you want to let me share? I'm not frozen. I'm just waiting. Oh, here we go. All right. So now I can do that. And everybody should see the presentation here. So thanks for the great introduction, Paul. Looking forward to any questions that may come up. I do really enjoy talking about surge protection and helping customers keep their radios up and running, avoiding signal interruption, power interruption, and making sure that no one has to climb a tower unnecessarily to replace a radio that could have been saved if the proper surge protection was installed the proper way. So we're going to focus on that subject today. We're going to go over a few different things. We'll talk about what a surge is, so everybody can understand the event and how it's caused. We'll talk about the technology in surge protection, and then we'll go into the different applications, the three major applications we see out there for fixed wireless radio installation, which would be your Ethernet applications, your DC powered radio applications, and then any radios that have coax ports or using coax cables. So we're going to start off by just making sure everybody understands that Transtector PolyPhaser, we are part of the Infinite Electronics family of brands. Infinite Electronics owns and operates all 13 brands you see up here. We work closely with our partners like MBSI WAV to make sure that all of these products are in stock, ready to ship same day. If MBSI WAV doesn't have the answer for you as far as technical support goes, we have 24/7 technical support available for you. In addition, I have no problem providing everybody with my email address and phone number. If you have any questions, you can reach out to me as well. Transtector and PolyPhaser, we are pretty much the brand for surge protection. Everybody knows those two brands very well. We've been around for 50+ years. We're involved in a lot of the committees that write the standards and test procedures for surge protection. And we have every type of surge protection required to protect an installation, RF, AC, DC, and data line protection. And as I mentioned, all these products, we put them in stock, ready to ship same day. So what is this surge event? So a surge event, it's different than any other power quality anomaly out there in that it's so fast. It's a microsecond event. So these microsecond events can cause different types of damage. You can have the type of damage where you may have a radio that you thought you were going to get 20 years out of, but because of low-level surge events, you only get 10 years out of it. So surge protection can help eliminate that event that degrades equipment and gives you a premature end of life of equipment you wanted to last a long time. We could also see events that interrupt. So it may cause brief damage to a system and then the system resets, but you've lost signal, you've lost power, your clients, your customers are experiencing an outage. And then we have the damaging effect where you get such a major event that occurs, this microsecond surge event has so much energy behind it that you end up with damaged equipment that is unrecoverable and needs to be replaced. So surge protection can eliminate those three types of problems you see from those microsecond transient events. So we have equipment out there that's sized to a nominal rating. So most of our radios out there, let's say DC powered radios, are 48 volts DC, right? So we want to size and choose the surge protector and design the surge protector to react right above that nominal rating of the equipment, okay? And I'm going to talk a little bit more about that in just a moment. Another important thing to recognize is the fact that a transient event, like I said, it's different than other power quality anomalies out there, like an overvoltage, in that it's so fast that you have to have surge protectors because they're designed to react faster than that surge event, right? So an overvoltage event, an event where the utility may cause something where they're sending you a voltage above the nominal rating for a long period of time, those kinds of events, we want to use breakers and fuses for those types of events, right? They're designed to react in a timely fashion that will take that overvoltage event and make sure that humans or equipment don't get damaged from that overvoltage event, okay? So they react in seconds or sometimes minutes. So this microsecond event that we have with the transient surge event, we need surge protectors because they react in nanoseconds, okay? And some surge protectors may react in 2 nanoseconds, some may react in 5 nanoseconds. Fantastic. In the grand scheme of things, you just need a surge protector that's going to react faster than that microsecond event, okay? So surge protectors being designed to react in nanoseconds will help you eliminate the faster, that fast microsecond surge event. So I talked about nominal voltage and turn on, right? We want to turn on just above the nominal voltage. So this diagram you see here is a typical power system where you may have your AC current coming into the system, and normally that AC current is fine and the surge protector sits off in parallel and it doesn't do anything, okay? It's just waiting for that microsecond event. So then when we see that microsecond event or that spike on the normally fine AC sine wave, when we see that spike, that surge device now becomes the path for that surge energy to go in. We react and we capture that energy and we divert it to ground. And that reaction time is called voltage protection level, or VPL, okay? And not all surge protectors are created equally. Some surge protectors use components that react faster than other components. And you can see that reaction time in that VPL rating of the surge protection device. So we want that VPL rating, the voltage protection level, to be down close to the nominal voltage so that we capture that spike and get rid of as much of that that surge energy as possible before it can go downstream and damage the equipment. The different technologies that are used, as I mentioned, have different types of reaction time. okay? So there's three major components used in the surge protection world today. GDTs, or gas discharge tubes, and gas discharge tubes are good, right? They're very robust. They're used very frequently. We use them in a lot of our products. They don't have a very low turn on time, and as the name indicates, a gas tube has a gas in it that ionizes to create that path to ground. And after every event, that gas takes longer and longer to ionize, and therefore you end up with a turn on voltage that creeps up after every event, right? And then eventually you're going to reach an end of life. A gas tube has a rating on it. It'll say, if you look at any gas tube spec, it'll say, oh, this gas tube can take 500 5 amp 10 by 1000 surge events, right? So you'll see a rating on there. And then after it reaches that it's seen that many events, it's reached end of life, okay? Metal oxide varistors, or MOVs, came along after gas discharge tubes. They are an improvement over the deficiencies of the gas discharge tube in that the turn on voltage is lower than a gas discharge tube, and they take longer to degrade, okay? So you do get an improvement. They're very robust, but like the gas tube, they also have a shelf life. They can only take so many events before they reach end of life and need to be replaced. Silicon avalanche diodes, or SADs, they don't degrade, and they have a really low turn on voltage, okay? So now we get this super fast reaction time that can be ideal in a lot of different applications. Now you may say, okay, fantastic, I want SADs in everything. There's no perfect surge technology, as you can see here. SADs actually, they do have a deficiency in that they can't handle as much energy as an MOV or a gas tube. So there's no perfect surge technology, but we do at Transtector, we recognize the pros and the cons of all of the different surge technologies, and we try and leverage those to the best, and we use the right technology for the appropriate application, okay? So what are we worried about? There are three different things that can happen at a fixed wireless location. You can have a nearby event that induces energy onto a cable, and that energy will follow either up or down the cable to the equipment on either end of it, and either interrupt or damage that equipment. We also have the direct strike, less likely to happen, right? But if we have a direct strike on a tower or on a structure, then the down conductors, the tower itself or the down conductors in the facility, can induce energy onto those communication or power cables as well. And then the third event, the one that I see happening most often in fixed wireless applications, is when we get a nearby event that energizes the earth and lights up all the equipment that is grounded into the earth. And this is a little bit of a tougher one to wrap our minds around. So I got a picture here that I think will help the cause. So in a green space, we would install our facility housing our head-end equipment and our pole at the same time, each with their own dedicated ground systems. And then we would bond those two ground systems, right? So we would add a bond cable here between the two ground systems. So if this facility is already here, and then you go and add a pole, that's not possible to bond these two ground systems. So you're going to have a ground system under the facility that's not bonded to the ground system under your pole, your tower, your water tower, wherever that is. So now your cable becomes the only conduit between the two sites. So you have a lightning event come by, it energizes the earth, that energy populates through the earth, and as it's populating through the earth, it's spreading out and it's dissipating. So if it's moving and it sees the tower site first, it'll be at a certain energy level there. And then when it sees the facility over here, it'll be at a different lower energy level. So you have these two difference in energy levels, and now your cable becomes the common conduit for that overflow at the one site, and you'll have that energy populate onto that Ethernet cable or coax cable or DC line and go right to the head end, okay? So now it becomes imperative, vital, that we put surge protection on both ends of that cable, of that conduit between the two sites. And there's different ways to apply those power, Ethernet, and DC surge protectors that we'll talk about when we get there. So in the Ethernet world, keep in mind that surge protectors alone won't do the job, right? So we have to have proper shielding on our cables and proper grounding on the connectors on the cables to make sure that these surge protectors and the entire system is now impervious to those transient events that could populate onto the system in one of those three ways I mentioned. So we'll talk about Ethernet first, right? So for an Ethernet application, it's as easy as ABC. A, B, C. We want a surge protector installed at both ends of that line. There's no traffic cop sitting in between that, the top and the bottom of the tower that says, hey, surge event, I want you to go up to the top because that's where my surge protector, or hey, surge event, I want you to go to the bottom because that's where my surge protector is. That's not happening. So what you need to have, so that energy is going to go in both directions. So that's why you have to have protection on both ends. You need to use shielded cable and you need to use shielded receptacles with a dedicated shield to ground protection component in the surge protector itself, so that energy that populates on the shielded cable and then to the shielded jack has somewhere to go. So these surge protectors you put at the top and the bottom, the way Transtector designs these, they're going to be repetitive, okay? So we'll see an event, we'll take that event, divert it to ground, and then reset and be able to take the next event, okay? Now, under extreme circumstances, direct strike, high energy event, you may see the surge protector sacrifice itself, which will happen in a safe mode. The surge protector won't catch on fire, it won't burn up or anything. The way Transtector builds and designs our surge protectors, they're designed to sacrifice in a safe mode. So under that extreme event, that surge protector may sacrifice, but the good news is your radio hasn't been that sacrificial lamb. Instead, this, you know, lower cost surge protector has now become your sacrificial lamb. So the Transtector surge protectors encompass all of those characteristics I mentioned before that you'd want in a Ethernet surge protector. So we recommend, and we recommend these two products because it's future-proof for the system. We make other products that may not be PoE++. We make some products that may not be gigabit Ethernet. But if I just focus on these two products, I know I cover all the applications because these two products right here are both PoE++ rated. So they meet the latest IEEE 802.3 BT 100-watt power requirements. And they're both gigabit Ethernet rated, right? So that'll handle almost all of the data rates that we're seeing out there on most radios today. So both of these devices, the DPR F140, ALPU F140, have the same circuit topography in there, whereas each one of these has a dedicated gas tube and surge protector in series with each other that protect the copper pins inside the cable. So if you remember what I said before, what we've got here is a hybrid protection circuit that takes advantage of the best features of both of those components that I described to you before. You've got the SAD in there that has a super low turn-on voltage and doesn't degrade. It's going to do most of the work for your low-level events. But say you get that bigger event, we've got the gas tube in there to back it up. So fantastic hybrid circuit that gives you an awesome protection level. In addition, we have a dedicated shield to ground protection mode, and we have a gas tube on that dedicated shield to ground protection mode that's isolated and insulated from the protection circuits protecting the center pins. So now you've got shield to ground protection for anything that populates on the outer skin of the Ethernet cable. So that energy that follows the Ethernet cable goes to the jack, goes to the shielded receptacle in the surge protector, will now go to earth ground, right? Using that dedicated shield to ground protection mode. And then anything that could possibly get induced on the cables inside the Ethernet cable will go to ground because the SAD gas tube circuit is going to react and take that energy and get it away from your radio. So there's an outdoor rated version for the top of the tower and an indoor rated version for down bottom. So the indoor rated version can be installed in a couple of different ways. It can go on a DIN rail like this, and you can ground the DIN rail. It could go in a rack like this if you're using multiple Ethernet lines, and then you can ground the rack. Or you could use an individual version like this and tie a ground from the individual version to wherever your ground is. Okay, and the device is clearly labeled to show you which side is your line side and which side should be your equipment side. The ALPU F140 is available with a mounting kit, the ALPU Fit Kit. So it can be easily mounted on a pole or a tower. You want to take your mid-span cable, bring it in on the left. The shielded receptacle is there for your shielded jack. You want to bring your jumper cable out the receptacle on the right to your radio. And then you want to add your ground wire. We recommend a number 12 ground wire for this application. Remember, Ethernet cables we're dealing with small wires, so the amount of energy we're going to see is usually pretty minimal. So a number 12 ground wire is more than adequate for the amount of energy we could possibly see there. And then what's really cool is we have these grommets in here, weatherization grommets that you pull out. And what we heard from our customers, remember, we've been doing this for 50 years, right? So what we heard from our customers was often there would be condensation that built up in here and would corrode the jacks. And even though everything was great, they would lose signal or have interruption because of that corrosion. So especially if you're near any water or seawater, take these out, and now any condensation that builds up in here will have somewhere to go, and you'll eliminate that corrosion problem. Now, this is fantastic if you've got one radio up at the top or a couple of radios up at the top. If you happen to be installing multiple radios up at the top, we have a device called the MDPS, or Modular Data Protection System, where you can put up to 8 of those DPRs in here. It comes with 2, you'd get 6 more, and these are the same PoE++ SAD style surge protectors. And now you can protect up to 8 Ethernet lines at the top of the tower. So typically for the radios that our friends at MBSI WAV distribute, we recommend the ALPU and F140 and the DPR F140 for the SIA and Cambium Mimosa radios you see listed here. And then, so you know, I would say, hey, don't you know, you don't want to go low cost on surge protection unless, you know, you have to. Sometimes the cost of the AP doesn't justify it, right? If I have a $100 AP, do I want to put a $100 surge protector on there? So you might say, okay, I'm looking for a lower cost surge protector because of the application. And in that case, we have the ALPU L130, which instead of having a SAD gas tube hybrid circuit in there, it's gas tube only. Okay, so it does provide a good protection level, just not that higher protection level you get out of the F140. I also like to make sure people know, because I've heard it from people in the field, oh, I don't need a surge protector. I've got an injector, a PoE injector, or a midspan, and it's got surge protection built into it. We have a nice white paper that addresses that erroneous concept, and make sure that, and you can find it on our website, and you can make sure that you understand that. So you don't want your midspan or your injector to be your sacrificial lamb. You want the surge protector to be your sacrificial lamb, so that you can just go out there and replace that surge protector, which has a lower price point than your injector, and get back up and running as quick as possible. Okay, so we do offer a full line of PoE injectors, and we do have all of the cables that go in between the injectors and the surge protection devices as well. So now we're going to move on to DC powered radios. So we have a couple of nice, really nice surge protectors available for these applications. Transtector was really ahead of the game. We developed DC surge protectors before we saw this huge growth in DC powered radios out there. Again, being the pioneer in the industry, we really did a lot of research on the application and make sure that we designed these DC surge protectors to be able to offer an optimal protection level. So just like the Ethernet application, we're in the same situation where as easy as ABC, right? We want to put DC protection up at the top near the radio. We want to put DC protection down at the bottom at the head end. And then your C is providing AC protection from the utility source coming in. I'll touch on that a little bit at the end of the presentation. So the 1101-1110, our DC Defender, if you put a KT at the end of that, it comes with a mounting kit. And I'll show you a picture of the product in just a second. We recommend that for use for a couple of the SEER radios out there, as well as Cambium, those DC powered radios. And this will provide all the modes of protection you need. So in a typical DC application, we want to protect positive to ground and negative to ground at minimum. And then if you're going to ground either of those positive or negative lines, we have an added line-to-line protection circuit in our devices as well that will take care of all three modes of susceptibility of any DC system. So that 1101-1110 or DC Defender, you can see in the picture here, is a fantastic device. It's 100% silicon avalanche diodes. SADs are perfect for DC applications. If anyone's designed a DC circuit and you want to keep your DC voltage from going in a certain direction, what do you put in the circuit? You put a blocking diode in there, right? So we know that in DC circuits, diodes are optimal for the application. And in this situation, what you get again is a fast acting surge protector that will not degrade, right? You put this surge protector out there and you won't have to touch it down the road. No maintenance, it can handle whatever you can throw at, okay? So the DC Defender is a ruggedized aluminum enclosure. Inside of it are 4 ports, 2 for the incoming wires, right? For the main power cables coming up the tower, and then 2 more for the jumpers going out to the radios. And we know that there are some radios out there that use a 4-port, a 4-wire DC power connector inside the radio. You could actually come out of this connector on the tower top side with 4 wires if you'd like. So really, the DC Defender now not only becomes a surge protector, it can also be some DC distribution for you up there at the top of the tower. So down at the head end, there's several ways you can install DC surge protector. You can get a rack mounted unit for as many DC circuits as you have, or for the WISP environment, I see a lot of folks really like this 4-port chassis. So this 4-port chassis can either be DIN rail mounted, or it can go right on the wall or an enclosure. And if you use the 1117 module in there, you'll get your PoE. I'm sorry, that's for the Ethernet. If you use the CPX module, the DC protection module in here, you bring the DC powered cables in here and you'll get your head end DC protection as well. So in the DC world, we're seeing a lot of folks install multiple radios up at the top. So they're trying to bring either hybrid cables up to the top of the tower with your fiber and DC in one cable, or they're bringing a DC cable up and then multiple fibers up in a separate conduit. So we recognize that, and we also recognize that there's a lot of solutions out there today that don't really address the markets the fixed wireless markets. They're more designed for the carriers, either over-engineered, either overpriced, or oversized, okay? So what we've done at Transtector is we've said, okay, I don't really like these solutions out here. What can we do to provide the fixed wireless deployers out there a better option? So we came up with our DC Fortress, okay? And here's a nice picture of it, right? So the DC Fortress is a tower top enclosure where you can come into these terminal blocks here with up to 3 different DC feeds, okay? So if you want to be able to cycle the power to the radios from the bottom of the tower, you can run individual DC feeders up there, okay? Or here's a great value add and a great way to save some money. There, you can put jumpers in here and you can bring 1 DC pair up and then distribute out up to 3 different sets of jumpers to 3 different radios. So now you, and think about the cost of copper today, now you can only run 1 DC pair up here and save yourself the cost of running 3 DC pairs up the whole tower, okay? Off in parallel, we'll have a Transtector surge protector here. And then we have 2 spools over on the right for your fiber slack line. So you can come up with your hybrid cable in the middle of the big gland here, distribute your DC off to your DC blocks, distribute your fiber off to your fiber spool, connect your fiber connectors into this mux here, and then your jumpers can come off of this spool and go back out these grommets. Your DC jumpers can come back off of this distribution block and go out of these grommets here. I'll talk a little bit about the components. So the Transtector surge protector sits off in parallel, super robust, right? 30,000 amps of MOV surge capacity in here, and all 3 modes of protection I talked about. So we're going to provide you the positive to ground, the negative to ground, and the line to line ground as well. If the device were to sacrifice some rare occurrence, your power is still going to go through to your radios. So the beautiful thing here is a lot of the other solutions out there on the market today for this type of an application under extreme surge event, when they sacrifice, they'll cut off the power and you'll lose, or your clients will lose all signal and power reception. The WAGO cage clamps here are really cool in that you don't have to take any screwdriver out of your bag up at the top of the tower. You just use this little lever here, you open the lever and you put your wire in, you close that lever and it wraps around that cable, and you come back 30 years, you're gonna have the same integrity connection as you did when the first day you installed it. The slack line spools are in there so that you can have that slack line available to you in case you're going to move radios down the road, right? So it's a very user-friendly system that we actually got feedback from tower climbers when we designed this on how to make that look. And the glands at the bottom are unique in that they can accommodate different sizes of cables. So small cables, large cables, whatever it is, that gland will wrap around that cable and create a weather-tight entry point, regardless of the size. There's a latch on the side of the door that's lockable in case you want to lock that latch. Worried about somebody else going in there as well. So now I'm going to touch on RF protection. So PolyPhaser is the Kleenex of RF surge protection out there. Everybody knows the PolyPhaser brand. I see it in specs all the time. People will write, hey, install a PolyPhaser. They really mean to say RF surge protection. So why do we need an RF surge protector on a coax cable line? The major reason for it is when a transient event gets induced on that cable, right? And remember, we talked about the ways that can happen, nearby event or coupling from the tower itself. When that transient event populates onto the shield and the center pin, it's going to travel at 2 different rates and 2 different speeds. So if you had a 100,000 amp event populate on a tower, about 75% of that will bleed down the tower and go to earth ground using the standard ground system. 25% may populate onto your cables. So that 25% of that energy is going to follow down that cable, and it's going to follow the shield and the center pin. And when it comes into the facility, there's going to be a level on the center pin and there's going to be a level on the shield that are going to be different. So we put an RF surge protector at that entry point before the radio to equalize the potential between the shield and the center pin. And now when that energy comes down, that surge protector is going to divert it to earth ground, okay? In a lot of our surge protectors, we utilize a copper coil inductor type technology, and that inductor is tuned to recognize that lower frequency surge event and immediately divert it to earth ground. This is a nice picture of the inside of one of our more popular RF surge protectors. And what we show here is that there's a DC blocking capacitor on the center pin, okay? And then there's two copper coiled inductors on either side. It's a bidirectional protector. You can put it up there and install it either way, right? There's two copper coil inductors on either side that are tuned specifically to let your RF frequency through, but block the lower frequency DC event, okay? So there are a lot of different versions of RF protection out there. There are a lot of really cheap, low cost, not very well performing surge protectors out there. PolyPhaser, I know I'm biased, but PolyPhaser does make the best RF surge protector out there utilizing this inductor-based type of technology. So if you need an RF surge protector, make sure you're asking for PolyPhaser's inductor-based technology. And these are all OEM approved. We work with a lot of the radio OEMs to test and evaluate our RF protectors with their radios to ensure that they can meet the strictest standards out there, even from the carriers. Let's see. So I'm going to talk about that AC protection aspect I mentioned, right? So we spend a lot of time out there really concerned about our radios, okay? And that's very important. You know, there's a dozen radios up there, 6 radios, 3 radios. That's the bread and butter, right? That's where we're going to make our money off of our clients out there. So we want to spend a lot of time protecting those radios and making sure that whether it's DC, Ethernet, or coax, we've got the best protection and grounding on either end. But I see a lot of folks focus on that side and they forget about the utility side over here. Your site is being fed by utility power somewhere, and you don't know what that power is like, right? If you're co-located at a site where someone else has that AC power, you don't know what they've done. Do they have surge protection on that AC feed or not, right? And the utility is providing power to an aging infrastructure through an aging infrastructure to a growing population that is constantly making the utility provide us with power that isn't so clean, okay? So therefore, it's vital that you look at your AC feed as well, and there's different ways to protect that AC feed. If you want to protect it in the cabinet, you can do that with a plug-in device. And remember, a UPS is not a surge protector, okay? I hear that often. Oh, I've got surge protection in my UPS. No, no, no. Don't let your expensive UPS be your sacrificial lamb. Put a surge protector in between your UPS and the incoming power feed, and you can do that with a plug-in device, or maybe you want to do it with a DIN rail mounted device that would go in the enclosure as well. Or you could put a device at the main panel where that power is coming in, tie it into a circuit breaker in parallel, and the bonus there is now you're protecting everything that is coming off of that distribution panel by putting one surge protector in parallel off of it, okay? So we're also seeing a lot of places where they want an AC distribution cabinet with surge protection integrated inside of it. Transtector does this for a lot of our small cell customers. We do this for a lot of our fixed wireless customers. And I'm showing one version up here for a site where you may want to have 2 to 3 15 or 20 amp outputs. And this small little compact cabinet will provide you with a disconnect, surge protection, and AC distribution for up to 3 different outputs. And this is just one configuration. We've got these with multiple breaker configurations and multiple voltage and current handling capabilities. So maybe you don't want AC power in a cabinet. Maybe you want a cabinet that you just want to put that UPS in that I mentioned and a switch. So we have a full line of NEMA cabinets, polycarbonate, metal, you name it, every type of material you could think of, white and black, weatherized or non-weatherized. Do you want one that has a heater in it? Do you want one that has a fan in it? Do you want one that has both in it? Would you like to have that heater turn on at a certain temperature or the fan turn on at a certain temperature? We can send those out pre-programmed for different temperature levels. And we can also put AC and PoE power outlets in here as well. So any NEMA cabinet opportunities or applications you have questions on, just let the MBSI WAV guys know, guys and girls know they've been trained on all these cabinets. All right. So I promise you, I am getting close to the end here for questions. So hopefully, if anyone has questions, they've got them ready. So we don't make surge protection that doesn't work. We've been doing this a long time. We know our surge protection is going to protect your equipment. However, we still have customers who say, hey, I put a surge protector in and I'm still having problems. That's most likely due to grounding issues. So we do perform grounding audits, both virtually and live on site. We also provide carrier-approved grounding classes. So if there's anyone who wants to get educated on proper grounding and best practices in grounding, we reference all the latest codes and standards when we do the course. And when we do a site audit, so if you have a problem site, when we do a site audit, we don't just give you a report after and tell you to go fix it. We'll walk through everything with you and show you what we're discovering and how we're testing the systems as well. So it's almost like a double bonus there. You get the site audit and you get an education at the same time. Okay, perfect. So I've left 15 minutes for questions. Paul or Nicole, have we received any questions or gotten any questions in?
We have. Thank you, Jason, for that. That was great. We do have a couple questions that popped up. How about I'll read them out to you, and you give it your best guess, your intelligent answer.
I won't guess. If I don't know, I'll tell you, and we'll come back to you. All right.
Gotcha. All right. So in terms of a recommendation, what do you typically suggest using shielded Ethernet between the ALPU and customer equipment or non-shielded?
Okay, so the ALPU is normally up at the top of the tower, right? So because of the fact that now you're hanging out there and you're exposed, we recommend a shielded jumper cable going from the ALPU to the radio as well. Now, granted, you don't have as much real estate there for that energy to populate on, but I'd hate to have that be the reason why you have an issue, right? And not to mention, you know, you don't want to have that interrupted signal due to any induced energy that could, if you had an unshielded cable, induced energy could populate onto the center pin cables and cause signal interruption, okay? So we make kits, actually, and we've done this. We've got a complete kits where what we've done is tested the full system using shielded midspan with shielded jacks, our ALPU, and then a shielded jumper. And we've sent surge energy through that system with and without the protection. And with the protection, the radio survives every time. Without that protection in place, the radio does not survive. In fact, it sacrifices after the first event. So yeah, best practice is shielded midspan, surge protector, and shielded jumper cable to the radio.
Great, thank you for that. All right, moving along. So we've got a question with a quick follow-up as well from one of our existing customers, and it's reference to Cambium and their platform. So Cambium claims that the 820C has a built-in surge protection. Can you comment on that? And as a follow-up, Cambium does not claim DC protection is required at the top of the tower. Do you have any thoughts on that? I know we do on our end, but I'm curious what your input would be.
The first question is beautiful, right? I love it because it allows me to mention something I probably should have mentioned, right? I kind of touched on it on the mid-span injector port, right? So if you've got a radio that has surge protection built into it, and I've heard of other radio OEMs that have very robust protection built into the radio itself, so it provides some sort of surge immunity there. However, do you want that surge protection to sacrifice, then you have to replace the whole radio? No, you don't. You want that surge protector to be outside of the radio. Now, it doesn't hurt to have double protection there, right? A little extra protection in the radio itself. But you don't want to have to replace that radio just because a component level surge protector sacrificed. I worked with a radio OEM recently who was having I'm in Tampa. I worked with a radio OEM recently who was having problems out here. And I went out there, we took the radio apart, and there was a little tiny fuse link on the board. On every failed radio that sacrificed and opened up, it had to cost 20 cents. But those $1,500 radios, all of them had to go back to the factory and get reworked because that one little component sacrificed on the board. As soon as we put our ALPU F140 out there in front of that radio, they never had that problem again. So no DC surge protection required at the top. I imagine that's a byproduct of that. They're saying, oh, I've got DC protection in my radio, so you don't need additional DC surge protection up there. And I'll say, see previous answer to answer that one.
Absolutely. No, appreciate that. Couldn't agree more. All right, so moving along, a couple more here. Yeah, we got a handful of questions. So to protect the RF coax cables, in brackets, they've got a core and metallic shield. A polyphaser must be installed at the top and bottom of a tower, correct? Will all models of polyphaser do this?
Okay, very good. And I'll expand on the RF protection. So RF protection is divided into two worlds. You wouldn't believe this, right? That we could actually make RF protection even more complicated, right? But that's what we do here. So RF protection is divided into two worlds. You've got DC pass and you've got DC block, okay? Majority of the applications, you don't need to run power up the coax to the radio or to an antenna, okay? So you want to use a DC blocking polyphaser device in that application, and you only need it at the bottom of the tower, okay? Now, there are some applications and antenna for radios and antennas where they want to put power up the tower, an active antenna or a radio that receives power over the coax. In that situation, you want to make sure you're using a DC pass RF surge protector. And for polyphaser, that's usually our GX series. And it's a fantastic surge protector. And you would want to put one at the top and the bottom because now you've got that power potentially going both ways on that coax cable.
Perfect. All right. Next question. This is kind of a mismatched question. Can surge protectors be mismatched between the top and bottom of the tower? And is there something extra that needs to be done when mixing positive and negative voltage powered equipment on the same tower?
Okay, so the surge protectors can't be mismatched. We're very agnostic to whether, we don't really care whether or not you're grounding the positive or the negative in our device. So no, you can't mismatch any one. We have a catalog of DC surge protectors. We have several tower top versions, several versions you can put it at the bottom, and you can mix and match those however you'd like and not have any issues. I mentioned that these devices have a line-to-line protection mode in there, which means that there is an actual surge component across the positive and the negative inputs. And that surge protection component is going to react the same, whether you're grounding the negative or the positive side, it doesn't matter. So I think that answers the question. And if it doesn't, If I didn't, my email address is jmies@infiniteelectronics.com, or you can send Paul and Nicole questions and let me know if you want me to expand on that.
Absolutely. Yeah, you've covered a lot of content in here, and I could see how some people might be shy or have some questions. And yeah, that's definitely one of our messages is if you do have questions, you want to see this particular slide, you let us know, and we're here to help. All right, I think we've got a couple more that came in. See, we've got everybody intrigued.
Good.
All right.
Well, we're almost
next
at the
question here, Jason, is can a SAD be used to replace a GDT in most circuits?
So the difference between the SAD and the gas tube is the turn on time and the energy handling capability. So as long as so when I like to use gas tubes or MOVs over an SAD is when you have an application where the conduit is so large that it could let a lot of energy in, and therefore we want that higher energy handling capability. So I wouldn't say you can just replace them like for like. What you have to do is look at the application and say, all right, how much energy could I possibly be exposed to, right? So if I'm at the top of a mountain, at the top of a tower, I was going to say in Florida, but we don't have any mountains down here, but so you get the idea. If you're at the most exposed area in the world for surge, then I would say, and you get a large conduit, I would say you'd want to use an SAD and a gas tube, right? That's the best protection circuit you could possibly have. But I wouldn't just go ahead and replace an SAD with a gas tube if I was going to see a lot of energy. And I wouldn't replace a gas tube with an SAD. Sorry, I said that backwards. I wouldn't replace a gas tube with an SAD if I was going to see a lot of energy, and I wouldn't do the other one if I wasn't going to see a lot of energy and I wanted low turn on. Yeah, that one might be one where I need to probably learn more about the application to better understand what they're trying to figure out there, but hopefully that helped.
Oh, fair enough. Appreciate that. All right, moving along here. We're about 6 minutes, so we still got a bit of time. Okay. Are coax cable ground kits necessary when a PolyPhaser is installed?
Yes. We have a white paper I'd be happy to put out there, talks about tower grounding, and in that section of the coax, it does recommend that, I can't remember off the top of my head, but every 3 yards or something like that, you ground the actual coax cable to the tower. And so is it necessary? Is it not necessary? It's best practice, right? To do that. That way you're not relying on the PolyPhaser 100%. Give that PolyPhaser, a bit of a break. Try and bleed as much of that energy off of the coax as you can onto the tower as it's coming down. So yes, you should still ground that coax. Do you have to? If you have a PolyPhaser in place, you could probably take that risk and not do it. But again, it's best practice to ground that coax cable.
Perfect. All right, I think we got one last question here from the audience, and then we do have our skill testing question. So, oh no, another one popped in, okay. So this one is right up our alley in our backyard, but what is your confidence level for Northern Canadian temperature swings? So dealing with -50 Celsius to +40. We got wild weather up here. What's your confidence level?
As far as the surge protectors go, they're fine any weather. We do a lot of work with the railroads up there in Canada, and they love Transtector and PolyPhaser. And in order to be approved for the railroads up there, we have to meet their temperature requirements, which are extreme. On the high side, it's I think 70 C, right? It's crazy. So yeah, no problem. Our devices will work. I'm not so sure the radios will still be working, but our devices will survive the temperature fluctuations you have up there.
That's great. Oh, awesome. Appreciate that. So that actually, I was wrong. The next chat box that came in here was more of a comment, but so that actually wraps up all the questions that everyone has put out there. Like I mentioned, right, if there's further questions, don't hesitate to let us know, and we'll certainly get you the information that you need. So just to wrap things up, like I mentioned, we do have a skill testing question. So everybody get your chat window open. First one to answer will win a $100 Amazon gift card. And if you were paying attention during the webinar, and it actually came up in one of the questions as well, but real simple. What does SAD stand for in surge protection? What does SAD stand for? And we'll just give that 10 seconds. Oh, and there we have it. Bob Armstrong gets it right. Silicon avalanche diodes. And as we know, this technology is ideal for surge protection used in Ethernet applications because it has a very low turn-on level and does not degrade over time. So Bob, thank you for that. Everyone that's answered so far actually got it right, but Bob was the quickest. So we'll be in touch offline, Bob, and we'll make sure we take care of you. All right. Well, thank you, Jason, for your great overview and information today. We all appreciate it, and obviously we appreciate everybody that took the time to attend. Like I've mentioned, please feel free to get in touch with your account manager here at MBSI WAV if you have any additional questions or require any additional information on any of the product lines from Infinite Electronics. Obviously, we covered Transtector and PolyPhaser today, but that also includes KP, radio waves, Elcom, just to name a few. They've got a great team over there, and we love working with them, and they've got a number of product solutions that definitely help in the market that we're all living and breathing. As always, MBSI WAVE will be hosting future webinars, and we'll be sure to keep everybody posted on the information as it's released. Dates and times are regularly added to our website, and we encourage everyone to sign up to our mailing lists or follow us on social media to get front of the line for all opportunities. Also, as most of you know, we are 4 weeks away from CanWisp, and I know our team is absolutely looking forward to getting to see everybody in person, and looking forward to this event. If you are already registered, some folks from Infinite will actually be in attendance. They'll be at our booth, so any follow-up questions, product look and feels, they'll certainly be there to support that. If you haven't registered, question is why, but early bird discount has been extended to this Friday. So if you're thinking about it and you're on the fence, certainly have some opportunities to still get in there. We have heard that the hotel that's hosting it is starting to fill up. So get yourselves registered and get yourselves there. So that's all I have. Jason, thanks again. Very much appreciated. And thank you, everybody, and have a great day.
Thanks. Bye.